Hey y'all, it's your math teacher Mr. Boyden back at it again. Today I'm here to teach you about polygons. Okay, a polygon is just a closed figure in the plane. You may have thought of them as being called maybe like just shapes in the past. Okay, now not all shapes are polygons. They have to have segments as their sides. So for example, a circle is not a polygon. Why not? Because it's curved, okay? So the surfaces of it cannot be curved. They have to be straight. Each point where the sides or those segments meet, that's called a vertex. So if I zoom in on these polygons down here, let's highlight the vertices. Vertices is the plural form of vertex. So you have a vertex here and a vertex here, 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 and so on, okay? Those are vertices. And what's wrong with these? Why are these not polygons? Well, this one over here, it like closes in on itself. If they had connected the dots like this, then that would have been fine. That would be a polygon. Same thing over here. They just connected the dots in the wrong order. If they had connected them like this, then it would have been a polygon. This one's curvy. There's no way around that. This one's not a closed figure. What we mean by a closed figure is like an open figure would be like this, meaning we don't know what's the inside and the outside. Versus like if I draw a rectangle, clearly this is inside and this is outside. This one has an inside and an outside, but because of this curve, it also is not a polygon. This segment, it doesn't have an inside and an outside. It has like a top side and a bottom side, but there's no in and out. To be closed, it has to have an inside and an outside. All right. This you probably already know. So do you remember what we call a polygon if it has three sides? A shape with three sides? You should. That's a triangle. What if it has four sides? Do you remember what we call that? I wish I could hear what your guesses are actually, because there's usually a lot of different guesses to this question. So like rectangle or square or trapezoid, something like that. Actually, a four-sided shape is called a quadrilateral. That's the most basic name for a four-sided shape. And yes, squares have four sides and rectangles have four sides. Notice the pattern here. For triangle, you have like triangle, three angles. Quadrilateral, quad means four and lateral means sides. So like that's a literal translation to a four-sided shape. Five sides, I actually only know really one name for this one. That's a pentagon. And what if it has a lot more sides than that? So there are technical names for all these, like there's really long hexadeca, trifecta, whatever. Okay, but usually in class we don't do that. Rather than learning all those different names, what we do instead, like if it had 27 sides, we would just call it a 27-gon. And we do that so we don't have to learn all of that Latin and Greek and trying to figure out all of those crazy names. So we just leave it at that. So do understand that if you get, and because I want you to know that 6 is a hexagon and 8 is an octagon and 10 is a decagon. But beyond that, you don't need to know that 12 sides is a dodecagon. Okay, you can just say it's a 12-gon, and that will communicate clearly what you understand. All right, a little bit more vocab before we get into some problem solving. We need to talk about the concept of consecutive sides and consecutive vertices. I think I remember the first time I heard the word consecutive, it was about baseball. And they would say like, oh, Mark McGwire has hit home runs in 5 consecutive games, meaning 5 games in a row. So consecutive sides, and I'll color code this in with highlighter. Consecutive sides are just ones that are touching. They're next to each other. So these two sides are consecutive sides. Okay. This side down here is not consecutive because it's not touching. We skipped over these two sides on the left and right, so I'm going to get rid of that. Consecutive vertices are the same thing. It's if you're going around the shape, it's just one vertex after another. So like these two are consecutive because they're right next to each other. This one up here is not consecutive to those because you've skipped over these if you jump over to there. Okay, so that's all that means. So that'll sometimes come up in a story problem. So it's vocab that we should know. We also, just like we did with line segments, we need to learn how they're named. The most important thing when you name these is the vertices have to be in consecutive order. And so let me show you visually what that means. When they say pentagon, A, B, C, D, E, what that means is I should generate the shape if I trace those letters in that order. A, B, C, D, E. And you are allowed to go back to A from there. Same thing over here, triangle, A, B, C. So A to B to C, and then you're allowed to go back to where you started. I just traced the shape. So these are correct ways of naming the shape. Let me show you a way that would be wrong. So if we said pentagon, A, C, E, B, D. And I want to show you what that would look like. So that would look like A, C, E, B, D. That's not the right shape. In fact, I didn't hit any of the sides of the shape. That makes some sort of a star. Okay, and that's a whole bunch of shapes. So that's totally wrong. So what's important to understand here is the order matters, and whatever order we show is the order that you would trace out to make that shape. And so here we have an example, okay, of two that are congruent to one another. And this is kind of a big picture, so because you may want to pause the video if you want to have this picture in your notes. So if you need to pause, feel free to do that now, because there's a lot going on here. The purpose of this visual is to show you that the order matters. So we have camp is congruent to site. These are our two, looks like they're kind of like trapezoids. They're definitely quadrilaterals. So here's what's important. C is the first letter, and S is the first letter. Let's identify those. If they're congruent, C and S have to have the same markings. There's no way out of that. Okay, and look, they do. What about A and I? Those are the second letter in each one. So A is right here. A has a double marking. I is right here. I has a double marking. Another way to see this is, what if I took the last two, MP, and I looked at that as segment MP? Notice that segment has a triple marking on it. If I take the last two letters over here as well, TE, then TE also has that triple marking. Okay, so this is what's called corresponding parts of the shapes. So the parts that are in the same spots on the shapes. And if the shapes are congruent, then each of the parts of the shapes also have to be congruent. Because remember, congruence is basically saying that the two shapes are the same in every way. And so it makes sense that, well, yeah, of course their angles and segments would have to be the same. But they're the same in the same order with the way they're written as well. All right. Do you remember what perimeter is? Perimeter, simply put, is just the distance around the outside of shape. So I'm going to write this two different ways. So you could say the distance around a shape or another way of putting it is the sum of the sides. And remember, sum means adding them together. So in our case, what we would do here is we would add these together, and my mental math, I'm going to say 5 plus 5 is 10, and 15 plus 12 is 27. Add 27 and 10 together, that's 37 centimeters. That is perimeter. Hopefully that's review for you. If not, you might need to go back and slow down the video, put it on literally on a slower speed and watch that again. But hopefully you remember perimeter is just adding stuff together. And if you remember that, that would probably be helpful in solving a question like this one. Finally, we're on to some problem solving. It feels like it's been a long time since we solved a real problem. So why don't you pause the video and attempt this one on your own. Finally, we get to do some problem solving. So what I'd like you to do, because this is a chance for you to really try it, is pause the video, attempt this question, and then when you're ready, watch what I do and see if we line up. Here we go. I hope you read the directions first before you tried this question. We should always read the direction. It's the worst habit that I see in any of my students is they just see a picture and they go, okay, I'm going to do this. They go, well, I don't know how to do it. Of course you don't know how to do it. You didn't read the question. There's information in there. So it's about, the question's about perimeter, and they told us that the perimeter is 20. Okay, so what that tells us is that all of the sides on this picture will add up to 20. Do I know all of the sides? No, I don't. Well, I kind of do, because I know that this mark here and that mark there are the same. So if this is 3x, that's also 3x. And so remember, perimeter is what you get when you add up all the sides. Well, let's add up all the sides. So we get x plus 2 plus 4 plus 3x plus 3x. And according to this, the perimeter is 20, so we can say equals 20 right here. Now, if you didn't get that set up, pause and let's make sure you understand why. Okay, it's just adding all the sides together. And if this is the first time you've seen this setup, this might be a good chance again for you to pause the video and try to solve this equation on your own. So give that a shot. Here's how I do it. I start by combining like terms. 2 plus 4 is 6. I'm going to pull all the x's together. 1x plus 3x plus 3x, looks like that's probably 7x. I'm going to subtract 6. And so I get 7x equals 14. Divide by 7. And so x equals 2. And that's it. So something that we probably have to practice. Once you get it, you'll think these are easy and you'll be really successful. For our next bit of definitions, there's just a couple terms that we need to kind of nail down and make sure we understand. The first one is equilateral. So the first part, it sounds exactly like what it means. It's equal. Lateral, if you didn't know this yet, you can translate lateral to meaning side. So equilateral means that all the sides are equal. So I'm going to write it as all sides congruent. And so if you look at all these pictures, that's what they have. They have the same markings on all their sides. All the sides are congruent. That contrasts with these on the right, which are not equilateral. For example, look, you have double markings here and single there, so not all the sides are the same. Or in this triangle, 2 of the sides are the same, but what about this one? There's no marking, so not all the sides are the same. So that's all equilateral means. It means all the sides are going to be the same. What about equiangular? So equiangular, that one might be even easier. It's equal angles, so it means all angles. So that's what equiangular means. All angles are congruent, or the exact same number of degrees. And we can see that in these pictures. Notice every single angle has the exact same marks. Contrast that on the right. Well, circle doesn't even have angles. This one has different angles. This one has different sides marked, and we don't know about the angles. And the triangle has 2 angles which are the same, and one which, well, look how small that angle is. That one is clearly different. Okay, so these are examples of not equiangular. What about regular polygons? So this one is not as intuitive, but look at the picture over here. And notice over here, so double mark, double, double mark, double mark. So it is equilateral. So I'm going to make a note. It's equilateral. And what about over here? All of the angles are the same too. So it's also equiangular. So sometimes my students will say, like, Mr. Boyd, come on, man, like more vocab, another one? Well, guys, the reason we say regular, it's so we don't have to say it's both equilateral and equiangular. Like, that's a lot. I mean, it really is a mouthful. Okay, so another way of saying this, an easier way, it would be saying all sides and angles are congruent. So like this one, the sides are not congruent. This one, the sides are congruent, but you have both obtuse and acute angles, so not all the angles are the same. Same thing here, different side lengths. Here you have different side lengths, so these are examples of not regular on the right. So let's answer our final question. And here it is, and I want you to pause the video and consider it first before I tell you what the answer is. And the question is, what is wrong with this picture of equilateral pentagon ABCDE? Our first place I want to look is they said equilateral. Is it truly equilateral? So I'm looking, all of the angles are the same. I'm not sure that all the angles are the same. So I can't tell. Is it really equilateral? I don't know. It's definitely equiangular. But there's another issue that's bigger than that, and I'm wondering if you got this one. So if I trace out A, B, C, D, E, so I need a different color. A, B, C, D, E. it makes that shape. So there's actually two issues with this. So the letters are in the wrong order. What should they be? They should be, if I trace A, C, D, E, B. So A, C, E, D, B. Okay. It should have been that. And so that's fixed, and it's also equiangular. All right, y'all, that's basically it for our introduction to polygons. I hope you enjoyed the video, and I'll see you next time.